Okay, so this is chapter 10, Interpreting Linear Equations, which is from my book, Overcoming Digital SAT Math. So remember, if you have a copy of this, for the best results, attempt the problems on your own first, and attempt doing corrections on your own first before referencing this video after for anything that you're stuck on and can't correct on your own. So let's go to... Oh, and also you can go to the matching ACT video if you need like a little bit of a review or something before this, which I'll link in the description. So let's start with number 1. So it says a landscaping company needs to budget for an upcoming job trimming trees. They represent their estimated total expenses for trimming trees with the equation 500 plus 15xh, where x is the number of workers trimming the trees and h is the number of hours it takes to finish trimming trees. Which of the following is the best interpretation of the number 15 in the given equation? So right away, I'm seeing that 15 is being multiplied by not just one variable, but two variables here. So in the context of a linear equation, that would mean that 15 has something to do with like we would refer to it as the rate, the slope, that sort of thing. There's a bunch of different ways to refer to it, but those are the two most common ways that you're used to it. That's the total number of expenses, so that's going to be what's going up $15 per hour. Because remember, slope is change in y over change in x. And then this says that each worker's hourly wage is $15 per hour. That would make sense because then it would be $15 for every worker times the number of hours worked is what you're adding on to the 500 already to get the total number of expenses, which tracks with this whole situation. So that's the correct answer. Now we have a doctor uses the model above to estimate the speed s in beats per minute of a person's heart rate during a jog in terms of the time t in minutes between the time periods of 10 and 20 minutes. Based on the model, what is the estimated increase in beats per minute of a person's heart rate for each additional minute of jogging? Okay, so this is a situation where that trick that I said, the per, the each, the everything, helps you out more. Because they're asking you what is the estimated increase in beats per minute, so you know that you're looking for slope there. Which, I mean, if this didn't give it away, this probably gave it away as well. So we're looking at the number that's acting as our slope, which would be the number being multiplied by the variable here, which is 4. Thank you for sharing and liking the live, guys. So let's go to number 3. Janet is purchasing clothes from an online store. The store charges a one-time shipping fee. The equation represents the total cost, C, in dollars, that Janet will pay for n items. What does the 20 represent? So again, this is the same thing as y equals mx plus b. Like, it's the same format. It's just instead of using an x, it's using an n, and instead of using a y, it's using a c, but the same rules apply. So 20 is acting like our b, our y-intercept. And some keywords that'll help you out on the exam are like anytime it says one time or like fee, those are typically going to be indicators that you're talking about the y, what's acting as the y-intercept. Or if they use the word initial or start, those types of words. So in this situation, that's going to be the one-time shipping fee, the 20, because think about it, it's $45, what is n again? $45 for each of the n items, and then you're going to add on the shipping fee of $20 to get the total cost. So that's the cost of the shipping fee in dollars. Okay, so let's go to number 4. Yes, it's B. Amy's checking account balance, B, in dollars can be modeled by this, equation right here, where W is the number of weeks since she first opened her checking account. Based on the model, how does Amy's checking account balance change each week? So here is another keyword. I think I mentioned like rate of change. It doesn't always have to be with the word rate. Sometimes it's just like change and also like each right here. Those are kind of like some giveaway keywords that we're talking about slope in this situation. So I should be looking at the number that's being multiplied by my variable here. So I should be looking at negative 20, which that means if it's negative, if I have a negative slope, it should be decreasing. So I should cross out A and C, and it's decreasing by $20. So it's going to be D. Yes, you are correct. And thank you guys for liking and sharing the live. It really helps out. Oh, I almost skipped number 5. Okay. Number 5, while training for a marathon, Lexi created a running schedule in which the distance she ran each week increases by a constant amount. If Lexi's running schedule requires that her longest run is 10 miles in week 4 and 22 miles in week 12, which of the following best describes how the length of her run changes between week 4 and week 12 of her running schedule? Okay, so, again, you have that word changes. Doesn't really help you as much like with this type of problem, but it's a little bit helpful, because it tells us that we're going to be doing something regarding like rate of change slope. So let's see, it's going to be 22 miles minus the 10 miles. So I'm going to put miles right here just so we can see the units. And then it's going to be 12 minus, not 10, minus 4 weeks for the slope or rate of change, however you want to think about it. So that's going to be 12 on top, and then it's going to be 8 on bottom. And remember, it's miles over weeks. So this is how it's changing. 12 miles every 8 weeks. Now you'll notice with this problem, you're not going to see those numbers anywhere over here. And that's because, and one of the reasons I love this problem, is because you can think about this in this number, this value, in several different ways. Like you could completely simplify it. You could say, okay, the greatest common factor is 4, divide by 4 on top and bottom, and then you're going to get 3 halves, but you don't see that number there either. So you have to think, okay, maybe it's not fully simplified. So what we're going to do instead of dividing by 4 is let's try dividing by 2 on top and bottom. So if I divide by 2 on top and bottom, I get 6 miles every 4 weeks, which is consistent with answer choice C. Is this the, yes, the formula that you just said, that's slope formula. Yes, correct. Let me just erase this right here. And please like and share this live to get it out to as many people as possible. It really helps out. Okay, so let's go to number 6. A factory produces car parts. The cost to produce a single car part consists of a fixed cost of $5,000 plus a variable cost of $25 per part. If the total cost to produce 800 parts is represented by the equation, this equation, what does X represent in the scenario? So we want what X represents. Really quickly, I want to just point out also, like, they like the word fixed, like fixed cost, fixed fee, for y-intercept. And variable cost is, that's less common, I would say, but it is like another keyword you can watch out for. So we want to know what X represents. So it's $25 per part. So this 25 is your slope. And it's $25 per part. So whatever it's like per or each or every, like whatever it's indicating like comes after that is going to be the units for what you're multiplying the slope by. So this is going to be in parts, in car parts. So let's see, that's going to be the number of parts produced, A. Okay, yes, for everyone that said A, good job. Okay, so this one, we're going to use this information for questions 7 and 8. So it says the given function P models the annual corn production in Brazil in millions of metric tons between 1997 and 2017, where X is the number of years after 1997. So we have this right here. And then we want to know for number 7, which of the following graphs best represents the model. So the first easiest part is to identify, like I know that this is a linear equation or linear function because there's no crazy like radicals or like exponents or anything like that. It's just regular old X. So I know that the number floating on by itself over here, 22, is my y-intercept. So right away, I'm going to look to see, okay, is the y-intercept at 22? Yes. This one's at 22. Yes. this one's at 0, so it definitely can't be that one. It can't be C. And this one's at 0 as well, so I've already been able to eliminate half the answer choices by just referencing the y-intercept. So now I'm going to look at the slope, 3.7. So remember, slope is going to be the change in y over the change in x. So let's see. Let's look at two different y values basically. And you don't have to be exact with these because typically when they give you these types of problems, unless they like mark a specific point on it, you don't have to be exact. They're expecting you to estimate. So it's totally fine to be like, oh, I don't know exactly where that is, but I'm going to like guesstimate it basically. So that would be probably about, let's see, these are each going up by 10, 20. Yeah, they're each going up by 10. I don't know. Let's say that that's like, I'm really bad at guessing based off of like eyeing it, but 54-ish maybe. So 54, and then the y-intercept is supposed to be at 22, so we'll say that minus 22 over, and then let's say this looks like it's lining up with 20 years, because remember each of the boxes is 10, and then minus 0 is lining up with the y-intercept is 0, 22, so like the x value would be 0 there. So this is going to be 32 divided by 20. So let me just put that into the calculator. 32 divided by 20 is going to be 1.6. So that's like way off, so it's probably going to be B, but let's just prove it to ourselves. So this, let's just say that looks about halfway-ish, a little bit more maybe, for the box. So let's say it's like, I don't know, 95-ish, minus 22 over, and then this is lining up with 20 right there, and then minus 0. So that's going to equal, let's say that's going to be 73 over 20. So then it's going to be, punched it in wrong. 73 divided by 20. I really need to get a calculator. I keep forgetting. And that's going to equal 3.65. So that is fairly close. Remember, I said it doesn't have to be exact. Like, they're expecting you to guesstimate. So 3.7 is fairly close to that. It's B. Can you explain, nice, I haven't seen a question like that before. Actually, this is so helpful. Can you explain how you solved for it briefly? So all I did was, I think you're the one that said that, referenced the slope formula. That's all I did. I just picked 2 points. So I guesstimated where this point was and where this point was, and I plugged them in for slope to make sure I got something close to 3.7. Same thing over here. I did this point, and then just plugged into slope formula. That's it. I'm glad you're finding it helpful though. So let's keep going. Whoops, oh, here it is. Okay, according to the model, what is the best interpretation of 3.7 in this context? So remember, 3.7 is our slope, and we have to think of the units because slope is the change in y over the change in x. So if we're thinking in units, well, what does y represent? Y is going to be the annual corn production in millions of metric tons. And then the x is going to be the number of years, which you can see in like the answer choices there as well. But you also know from like the context of the problem. So we're thinking about annual corn production, how it's changing in millions of metric tons over the number of years, or like each year, every year, per year, whatever you want to think about. So let's see which one of these says that. That would be B right there. It says each year between 1997 and 2017, Brazil's annual corn production increased by 3.7 million metric tons. So it's increasing or changing by 3.7 million metric tons each year. So that matches up.